this up. Let's get going. All right, here's where we're going. Quiz 2 is fully dedicated to how to find an angle. Any type of angle, inside, outside, in between a circle. So for instance, here on this diagram, we should be able to find angle D and know how to find it. It's inscribed. Or we should know how to find angle CEB. That's a floater angle. We know all those rules already. We're going away from angles, and this last part of the unit is going to focus on lengths. So how long is AE? How long is DE? That's what our focus is now. This last part of the unit is how long chords, tangents, and secants are. Now, I know you're so excited that we're going to start off with the proof. We're actually not. I'm not going to do this proof. All right, I'm going to save ourselves some time and headaches, and I'm going to go right to the theorem at the bottom of the page and give it to you. All right, we're going to go right to the theorem at the bottom of the page. Before I do that, though, you are going to have to do some work for me, though. What's CED called in this diagram? CED, what do we call that? Refresh our memory, please. CED, what's that called right there? Tess, welcome back. Here you go. What's CED called? Just a what? Chord, yeah, it's a chord. And so is AEB. That's a chord. And notice everyone, they're intersecting each other. That's what has to happen for this fact I'm about to give you the work. You have to have two chords intersecting. All right, so we're going to start this theorem off by saying when two chords intersect. Okay, so you have to have that diagram there. Two chords intersecting. Only time this fact works. And what happens when two chords intersect? Here we go. The product. So what's going to happen? Anybody associate a word with product? We're going to multiply here. All right, we're going to multiply. The product of their parts are equal. Go back up to your diagram for me. Go back up to your diagram. So we can actually now use letters now. All right, Tess said that CED was a chord. It's broken up into two parts now, isn't it? After it was intersected by the other chord, chord CED is broken up into two parts. Name those two parts. Name those two segments it's broken up into. Where are we going here? Good talk. Alexi, what two parts is CED broken up into? Right? CED, this chord is being intersected by the other one. And when it got intersected, it's broken up into two pieces now, two segments. That's what I want. Those two segments are what? This chord right here is intersected by this chord. So this chord CED is broken up into what two parts? I want the names of it. This name, CE and ED. So CE times ED. I multiply those two parts, and now take a look at the other chord that's being intersected. It is also broken up into two parts. So name AEB is broken up into what two parts now? AEB broken up into two parts. Brendan, what are they? Yeah. Good. So these two multiplied equal the other two parts. Multiplied BE and EA. Right? That's how this works. Two chords intersect. Part times part equals part times part. Right? That's how this fact works. Questions? Got to have two chords, though. Two chords. Right? And they have to intersect each other for these. That's why, hey, if anybody's wondering, hey, look at the diagram. CB is a chord, isn't it? But it doesn't intersect another one. So that's why we're not using CB or AD here. It doesn't work. All right, let's do some numbers now, some algebra. All right, everyone sees two chords intersecting on this first one. Name two parts of one chord that it got broken up into. One chord got broken up into these two parts. Name them. Or their lengths. Their lengths. Name their lengths here. Dylan? And? Okay, so we're going to say 8, the product of 8 and 2.5 equals the product of the other two parts. So now go look at the other chord. it got broken up into what two parts? What two lengths did it get broken up into? Stephanie?
2 and x.
Good job. There you go. So 2 times x. Everyone's seeing how it works now. Now that I'm actually putting numbers with it. So when two chords intersect, multiply 2 parts of one, set it equal to 2 parts of the other. I think we get 20 there. And I know mine goes in a different, I'm going to stay in your order. Don't worry. I know mine slide up here doesn't go in the same order, but all good before I increase the difficulty as we move along. Boom. Oh, so sad. Looks like we're going to have to draw a diagram for this one, huh? Looks like we're going to have to draw a diagram. All right. Let's draw a diagram then. Ripping out 2 chords here, A, B, and RS. Intersect at point E. Everyone's throwing a 3 on AE and a 16 on EB. And then as you read the rest of the problem, oh, I have 2 segments in a ratio. Okay. I'm pretty confident in you. We did this all for quiz 2 when arcs were in a ratio. I don't want to put 3 and 4 on there. What do I want to put instead on RE and ES? I don't want to put 3 and 4. Instead, I'll put Shar, what am I going to put? X's, right? So on RE, everyone throws a 3x up there, and everyone on ES is going to throw a 4x. All right, 1 chord is broken up into 2 parts. Name those 2 parts. Take a chord right now. Give me the 2 parts. Stephanie, back to you.
3 and 16.
3 and 16. So 3 times 16, their product equals, name the other 2 parts of the other chord. We're flying now. We're flying. Shoom, Lily?
3x times 4x.
Good, 3x and 4x. All right, the geometry's done, ladies and gentlemen. The geometry's done. Oh boy, how about this algebra now? Yikes. Yikes. All right, so everyone's doing 3 times 16. That's cute. 48. All right, what are you doing over here now? 3x times 4x. Gonna make any algebra teachers proud in here. All right, what do you got? Let's do this. What do you got? Oh, there we go. Nope, going again. 1, 2. Jonathan, what do you think? 7. Are you adding those? Are you adding those 2? What are we doing between the 3x and the 4x? What's the operation? Well, there's nothing to distribute. We're multiplying, right? So you want to tell me 7. 12x, and we're missing something. You have x times x. So it's got to be squared up there. All right, 12x squared when you're multiplying them. All right, I'll still listen. What do you want to do next? Got to get x by itself. I'll listen, right, wrong, doesn't matter here. All right, Jonathan, let's roll. What do you want to do next? Hey, there we go. Divide by 12. If anybody was thinking take the square root, not until x is by itself. X squared needs to be all by itself before you take the square root. There we go. Now we're going. X squared equals 4. Next step here. Next step. Ooh, Stephanie, back to you, on fire today. Good to hear from you.
Get rid of the 2, so I'm not sure.
It's all right. You want to draw it in the air for me, or
Yes.
square root both sides? Yeah, radical. Yeah, I got you. Little charades there. So x is usually, hey, whoa here, kids. Usually we put plus or minus 2 when we take the square root. Does it make sense to put a -2 for x? Now, I can't have a negative length. That's silly. So yes, x is 2. Now I answered the darn question. because we need to define RE and ES. Length RE. Dylan, length of RE. Thanks, 6. And then how about ES over here? ES. Oh, Tess, back to you. 8, good. And real quick, 3 times 6, 48 equals 6 times 8, 48. Everyone see the two pieces multiplied together equal the other two multiplied. Questions on that one? Because we're only going to get a little tougher here. All right, let's go. Keep feeding the beast. Let's go down to this one. All right, how long is chord CD? All right, it's 3 centimeters from the center. Can you put, where's the 3 going then on your diagram? That chord CD, 3. 1, 3. 3 centimeters from the center. So where's that 3 going right now? That chord is 3 centimeters from that black dot. 3. All right, did we pop the 3 right here? Hopefully 3 centimeters from the center. Yep. And the radius is 5. Keep putting stuff on your diagram. You should, now that you know the radius is 5, keep putting lengths on. Okay, yeah. Great job putting a 5 here, but you could have put something else here too. What else do we now know the length of? What else? I could put a 5 there because that's the radius. What else could we put on this diagram if we know the radius is 5? Your best ability, Brendan, talk to me.
The other side would be 5.
What do you? Well, this from here to here is 5. Yep, I got that, but that part's already 3.
Oh, you can put the 2.
Darn right. Put a little 2 over there. So everyone's all right with the labels. Look at the chord now, CD. Hey, I told you stuff on quiz 3 wouldn't come from quiz 2, but we still may need a factor 2. What is happening to that chord right now? Based on what we've done here, our facts, what's happening to that chord? It's getting bisected. Why? Diameter, perpendicular to a chord, bisects the chord. Yes. So that chord is getting bisected. So I know those two pieces are equal. So why don't we just put X and X there, right? Once I find one, we can double it and find the whole thing. Let me go back to our theorem we wrote down at the beginning. When 2 chords intersect. Now look at your diagram we're working on. I see chord CD. Is there another chord in this diagram I'm not seeing? I see chord CD. Is there another one? Yeah, because remember, what's AB again? Diameter, which is a chord. So you do have 2 chords intersecting right here. AB intersecting chord CD. Let's start with chord CD. Chord CD is broken up into what 2 pieces so I can multiply them? Chord CD is broken up into what 2 pieces? Whoo, going deep here, Lauren. It's broken up into? Yep, everyone ready? X times X. The 2 parts of one chord. Now, lock in here. Now go to the diameter. The other chord, AB, is broken up into 2 parts as well. And it's always broken up right at the intersection point. So tell me what the length is on each side. It's not 3 things I'm multiplying. It's only 2. So chord AB is broken up into what? 2 parts from its intersection point. Here we go, Charlotte. What's one length? 2. Ready? I'll highlight it as she does it. 2 right here, this part, times the other part. Ooh, I need the whole thing, though. You're only giving me this part right here. I need the whole darn thing, which is 8. Everyone seeing where that 8's coming from? Part 2 times the other part, 8. Got to give me the whole thing. Questions on how we set that up? And the parts always start from the intersection point on each side of the intersection point. X squared equals 16. What do you want to do on both sides here? Just making sure we know. Jared, what do you want to do when x squared equals 16? Darn right. X equals 4. You didn't win anything, though. You didn't answer the question. X equals 4. How do you want to find the chord then? Chord CD. Whoa, Zoli, how do we find the chord then?
You would add both of the x's together.
There you go. So 4 and 4. That chord's a length of 8. Nailed it. Any other questions there? Oh, you thought that was tough? Oh, yeah. There it is, the beast. This last one. Do you see 2 chords intersecting? Okay, so I'll highlight them on mine so you can see it. Here's the first chord I'll do in yellow, and the diameter is acting as the second chord, which I'll do in blue up here. So I do see 2 chords intersecting. All right, give me the 2 pieces of 1 chord we already know. Give me the 2 lengths that you already know of 1 chord. Lauren, go ahead. 1 chord is definitely broken up into what? 8 and 10. So I'm definitely going to multiply 8 and 10. We're good. Now look at the diameter. You already know it's broken up into 1 length, which is what? What's the 1 length we know of the diameter? It's broken up into, Stephanie, back to you. That diameter is at least broken up into a length of, okay, yep, good. Stop there. X. All right, here's where I'm going to help you out. What about the rest of it? Take a look. It's got to be from here, the intersection, to all the way here. That's the length I'm looking for, that red segment I just put up there. That's what I need your help in, so I can plop it in my parentheses here. How long is that red segment? What's the 12 up there? What the heck's that? Yeah, it's a radius, right? And what's this? We're calling it a chord, but it's also a what here? Okay, so how long is the diameter then? You told me the radius was 12, so the diameter's got to be 24, right? Everyone agrees that whole thing's 24. Okay, whole diameter, 24. That piece is x. What's the rest of it then? How can you write what the rest of it is then? We already know the whole diameter is 24. 1 part of it's x. What about the rest of it? 24, go, Cormac, 24 minus x. So 24, the diameter, minus x. We knew the whole diameter was 24 because we doubled the radius. Since 1 part of it's x, the other part's got to be 24 minus that. Oh, we're not even close to done with the difficulty here. All right, let's go. 80, everyone's good there, 80. We do a little whoop, whoop, little distribution there. What do I got? 24x minus x squared. Oh boy, there's going to be a lot of sweating, a lot of tears. Anybody know what I got to do next here? I don't know if this is a hint or not. You have an x squared and an x in the same equation. If I just had x squared, I'd talk about square rooting, definitely. All right, like where do we go here? Like I just had x squared here, so I'd square root. But now I got an x squared and an x. So there's no square rooting here. There's something else instead. Not our favorite probably from Algebra 1, but we're going to have to do it. Begins with an F. Ends in the opposite of an actress. What do we got, Lily? Come on, put the 2 together, yep. Yeah, let's go. Look at those clues. It is factoring time. Not yet, though. Not unless. Anybody remember you can't factor anything unless it's equal to 0. Now, I know it's very easy to get it equal to 0 by booting that 80 over. I don't know about you. I get very, very nervous and I sweat a lot when it's negative x squared. I do not like the negative with my x squared. I don't think you do either. So instead of going the convenient way and moving over the 80, I'm going to move everything over to the right side. Here we go. So move over the x squared. You get positive x squared. Move over the 24x. It becomes negative 24x. And we didn't move the 80, so that's going to stay plus 80. Equal to 0. All right. You're going to have to play games in your calculator. What game are you playing right now? The 2-number game. 2 numbers that do what in your calculator? Make sure we got this right here. Period 1 butchered this. What are you playing around with? Guessing and checking. Two numbers that multiply to which number up there? Oh boy. Oh boy. 80. Yes. So numbers that multiply to positive 80, but when you add them, give you negative 24. Go to it. A lot of numbers out there. Multiply to 80. Which pair will add to 24? As the typing continues. Anybody confident out there? Hopefully. Solely, what are you confident in?
Negative 20 and negative 4.
Negative 20, negative 4. They multiply to 80. They add to negative 24. Oh, look at us. Look at us. So x minus 20, x minus 4. Almost done. Now you got to take them out, set them equal to 0, and tell me what the values of x are, right? X equals positive 20. And x equals 4. Little game of are you kidding me right now. Look at those two answers and look at your diagram. Something's not flying here. I hate to break it to you for values of x. Something is not flying. I don't know, 3 minutes ago, you guys told me how long was the radius? 12 was the radius, right? Look at x. X is smaller than the radius. It's part of a radius. So which answer here cannot make sense? There's no way x can be 20, bigger than the actual radius, right? Okay, so we're going to have to take 20. And fellas, just like the story of with the ladies with some of you, rejected. All right? Rejected. So we just take 4. Okay? Hits home, some of you. Sorry, fellas. Anything else? Questions, comments? Okay, so there was the first fact for today. One more that still deals with chords. This one will go quick. I like this one a lot. Here's the other fact with chords. If they're parallel, before I go on, anybody remember the symbol? Not this symbol. That's parallel, yes, but on the diagram, what we put, two lines are parallel. Arrows, yep, good job, everyone. So if we, ready, bottom line, if two chords are parallel, arcs in between are congruent. Two chords parallel, arcs in between, AC and BD, they're congruent to each other. There you go. Okay, two chords are parallel, arcs in between, always congruent. I'll do number 1 with you. 2 and 3 are by yourself or in your group. Right away, AB. We see AB and CD are parallel. That means the arcs in between, CA and DB, are congruent to each other. Find one of those arcs, CA. Find one of those arcs. What do those 3 add up to? By the way, take a look at the diagram. What do those 3 arcs add up to? The 80 you were given and the 2 we just marked congruent. Those add up to what, Jared? And remember, CD is a diameter. Hint, hint. These 3 arcs right here. 180, right? Because it's a semicircle. Great job. So we're doing 100 or 180. Sorry, I just gave away that answer. 180 minus the 80 we were given. That gives me 100. And now I can divide that by 2 because they're congruent. So that arc's going to be 50 degrees. 2 chords are parallel. Parallel chords imply congruent arcs. All right, see what you can do with 2 and 3. Talk it over with people in your group. Do it yourself. Your call. And then I'll call in some people to finish it up. I don't need to call on you guys. You guys are working hard. I'll just give you the answers here. 160 and 60, 220, 140 here for arc CD. 140 degrees. Quickly though, for this last one in the corner here, bottom left-hand corner, remember, if this comes from quiz 2, if the chords are equal, so are the arcs. We needed that fact for this one. If chord DE and chord CE are equal, so are the arcs. All right, so those arcs are equal to each other. So there's two sets of arcs congruent to each other there. And if I remember correctly, the measure of arc DE, make sure you can find it, just don't write down the answer. 125. Okay. If you can't get that, let me know. If you can get it, you're good. I think all the assignments in the packet tonight. So we're staying in the packet.